Hello once again, and welcome to Simply Electronics Intermediate Episode 1. Today, we're going to have a look at this amazing circuit, which allows us to step up a lower voltage into a higher voltage with quite simple circuitry. You can see here there is a 9-volt power supply, but on the output of the circuit I have a voltmeter which is measuring the climbing voltage of this circuit. You can see at the moment I'm getting 68 volts. From a 9-volt power supply. This could be a 9-volt battery or any other type of 9-volt DC power supply. Before we go any further, I definitely need to mention, because we are now using higher voltages, you need to make sure that you stay safe. High voltages like this can give you quite a nasty shock, and it takes less than 20 milliamps to stop the human heart. So make sure you stay safe and don't touch any high voltage contacts if you are planning on using any high voltage circuitry. So what we are looking at here is a boost converter, otherwise known as a step-up converter. It is a type of switch mode power supply because it uses a type of switch, in this case it's a transistor, to turn a part of the circuit on and off at a really fast speed. Switching transistors are the main component in any type of switch mode power supply. So let's go ahead and explain how this circuit is taking 9 volts and stepping it up to a much higher voltage. Now this circuit is actually running a lot slower than you would actually see in person, because every circuit cannot process the speed of which everything happens because of lack of operating power. So in this case, as you can see down here, for every 1 second we are only viewing 300 microseconds of time, which is a very tiny portion of a second. So in real life, this voltage would climb almost instantly. So what I'm going to do is actually slow it down even more, and I'm going to stop the circuit and restart it. So we're now starting at 0 volts, and you can see here it climbs very slowly. We're up to 20 volts and closing in on 25 volts. So what's actually happening here? Well, if you watched my previous video, I definitely recommend you go and watch it, because we have an inductor in the circuit here. So make sure you understand inductors, which will definitely help you in understanding how a boost converter works. So I've actually slowed it down a lot more now, because it gives us more time to see what's happening. So now we're looking at 20 microseconds every second. If you've watched the previous video, when you pass current through an inductor, it creates a magnetic field. When you change the voltage passing through an inductor, the inductor's magnetic field will start to collapse, and thus inducing current through the inductor as it creates a high voltage spike as the magnetic field collapses. So this circuit is taking advantage of that very property of an inductor to step up voltage. So here we have this MOSFET transistor. So just imagine this as a normal on-off switch, but we can switch it on and off very fast. We can switch it on and off hundreds and thousands of times a second. So I'm actually electronically controlling this switch to turn it on and off with this power supply down here. Basically, I'm supplying power to the gate of this transistor, which just turns the switch on and off every 100 microseconds. When we turn the switch on, current can flow from the 9-volt power supply through the inductor, through the switch, and back to the 9-volt power supply. As we turn the switch on, and this current flows through the inductor, a magnetic field builds up in that inductor. Now when we turn the switch off, current can no longer flow from the inductor through to the switch. Because the magnetic field in this inductor needs to collapse and induce current through the circuit, because current can no longer flow through the switch when it's off, as you can see here, the current actually quickly flows through the rest of the circuit, and you can just see glimpses of it. As the switch here is open or off, current quickly shoots through this part of the circuit. We have a capacitor here in parallel. So anytime the current shoots through this part of the circuit, because the collapsing magnetic field of the inductor creates a high voltage spike, it gets pushed through this diode and gets stored into the capacitor. Because there is a diode here, this stops current flowing backwards from the capacitor through to the switch when it's on and back to the power supply. Every time we get a voltage spike from this inductor, this adds to the voltage of the capacitor, and therefore steps up the voltage. So the voltage we see on the top of the screen here is actually the voltage of the capacitor, and you can see every time this switch is open or off, we get this voltage spike from the inductor flowing through to the capacitor, as you can see here. Now, as I mentioned before, this would happen very quickly, and I'm quite sure this circuit would step up to around 100 volts. Now, just so you understand, as we supply voltage to this inductor, the inductor's polarity on the left side is positive, and on the right side is negative. when this switch is off, the polarity of the inductor changes. Instead, negative is now on this side and positive is on this side, which then allows the current to flow to the rest of the circuit because positive is connected to positive. So just to give you an overall view of how it works, let's press play from the start one more time and just watch how it steps up the voltage from 9 volts and how it just keeps climbing. If I could make this run fast enough, it would eventually settle at about 100 volts. Let's press play. So as you can see, this happens very fast, and in fact in real life would happen much faster. You can see it just steps the voltage up and continues to step that voltage up, and eventually it will settle out, but I can't run it fast enough to show you. So there you go. I hope you've actually learned something about boost converters and how they work. I will put a link in the description if you want to learn a little bit more about them. You can also interact and play with this very circuit. Just follow the link in the description. You need to be on Google Chrome to view it. You can even view or change around the circuit to get a better understanding of its operation. I will be doing a video on actually making a boost converter, so make sure you're subscribed to this channel. Stay safe, give this video a thumbs up if you enjoyed it, and leave any comments below.